Remember when I said this is the figure we're going to get very familiar with eventually? Which ones have we addressed already? We know that. We know that. This is what we call the divergence. This is what we call the curl, correct? This is just the definition of an E field. This is just the definition of the potential that we just talked about. Does this look familiar or not? It may not, but look at this. Just literally these two equations. Keep them with you. Ready? It's KQ over R squared and KQ over R. Yes? Going back to the crazy looking picture. This is K, correct? This is your charged enclosed, Q, over R squared. This, again, is your charged enclosed. This is just K. So if you want, you can write this as KQ over R squared. And remember, he does this funny looking R to tell you separation vectors. And in this case, the potential will just be KQ over that funny looking separation vector. This equation is your V equals ED equation. With me so far? And this is nothing other than E equals partial over partial X of V that we saw here. They have just generalized it to include the entire del operator in 3D. Okay, the only one we haven't talked about, technically, is this one. Do you know where that comes from? Can I just draw it here? Okay, that one is called the equation. Thank you. And how do I get to it? Okay, I will use the equation I wrote in here, the green one. So that is just my divergence of E. And I'm going to use this equation that I wrote here. With me so far? May I plug this value in here? What will I get? That is the divergence of a divergence that we did in chapter 1. And what was the result? Oh, and then the minus sign, right? Isn't that exactly what that equation is? So it's not fancy at all. It just seems scary when you first look at it. You just have to break it down into smaller chunks. And then it's not scary at all. Woohoo. Okay, anything else that, oh, yes. And I think Griffith also says, so what happens in a vacuum? Yep. So then your Poisson's equation will become this, and there is a name for this one. Laplace. Wait, what? But I just want you to see the big picture, right? I don't want to throw a lot of math at you without actually physically understanding that it's not difficult. It's actually quite easy, and it just flows from a few definitions. Honestly, the only equations I remember is the Ed equation and the fact that E is in the middle, and then everything else has to develop from E. Like once you make that table in your head, you don't have to remember all the details. You just have to remember the relationships. And that's why I don't like starting from Coulomb's law. I always starting from the E field, because that's fundamentally what holds everything together.